everyone, hope all of you are doing well. Today we are going to discuss the continuation of NCERT textbook exercises from the chapter Motion. If you have not watched till part 4, please watch it before going ahead with part 5. Now we can move to question number 3. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed for Abdul's trip? Here it is given that Abdul is taking an average speed of 20 km per hour to reach the school, and on his return trip he is coming with an average speed of 30 km per hour. Now we have to calculate the average speed for his trip. Here we don't know the actual distance and time, so that we can just assume that the distance Abdul commutes while driving from home to school is equal to S. So whenever you are writing, no need to write all the things in details. You can just mention that the distance from home to school is equal to S. And in the same way, we can assume the time taken by Abdul to commute this distance as T1, or the time taken by this distance is equal to T1. Now the distance from school to home is also the same, right? Therefore we can assume the distance again as S, that is the distance from school to home is also S. Here the time taken to travel from school to home is different, right? So we can take it as T2. And what are the other things given here? The average speed from home to school, right? So we can take it as V1 average. So that will be equal to 20 km per hour. And the average speed from school to home is also given, that is V2 average. So that will be equal to 30 km per hour. Here we have to calculate the average speed. So how we will calculate? We have to find the total distance divided by total time. So here we have the total distance, because S distance is traveling from home to school and from school to home. So total will be 2S. So that we can easily calculate. Now what will be the total time taken? That value we don't know actually. So that only the average value is given here. So that means V1 average is equal to distance by time, right? That is V1 average is equal to S by T1. So how we can calculate T from that? So T1 will be equal to S by V1 average. When we are rearranging that, we will get the value. That means T1 is equal to S by V1 average. That is the time taken from home to school. So in the same way, how we will calculate the time taken from school to home? Here we have V2 average is equal to S by T2, right? So that T2 will be equal to S by V2 average. So that total distance will be 2S, and the total time taken will be S by 20 plus S by 30. Okay, when we are substituting for T1 and T2, we will get the value as S by 20 plus S by 30. Now we can calculate the average speed, that is total distance divided by total time. Here we can substitute for total distance and total time, that is 2S divided by S by 20 plus S by 30. That will be equal to 2S by 30S plus 20S divided by 600. That is 1200 S divided by 50S. So the value will be 24 km per hour. Now question number 4. A motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during this time? Now what are the things given here? It is given that the motorboat is starting from rest. That means initial velocity u will be equal to 0. Then the acceleration is constant and its value is 3 meter per second square and time is 8 seconds. And we have to calculate the distance. How we will calculate the distance? Which equation can be used? Because it is given that it has a uniform acceleration, so that we can use equations of motion. So that first of all we can write the 3 equations of motion in one side. Okay, V equal to U plus AT, S equal to UT plus half AT square, then V square minus U square is equal to 2AS. Here U equal to 0, A equal to 3 meter per second square and time t equal to 8 seconds. Here we have the values of u, a and t, and we have to calculate distance or s. Okay, so which equation can be used? We can use second equation, right? That is s equal to ut plus half at square. And now we can substitute the values. That is s will be equal to 0 into 8 plus half into 3 into 8 square. So when we multiply, then we will get the answer as 96 meter. Hope it is clear to you. Next is question number 5. A driver of a car traveling at 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Another driver going at 3 km per hour in another car applies his brakes slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graphs for the two cars. Which of the two cars traveled further after the brakes were applied? Here we have to draw the speed time graph for both cases. In the first case, it is saying that the car was traveling with a speed of 52 km per hour and it is coming to rest within 5 seconds after applying the brakes. And in the second case, it was traveling with a speed of 3 km per hour and it is coming to rest within 10 seconds after applying the brakes. So we have to draw the graphs, and that calculation part also we have to do in order to find out which car travel further after the brakes were applied. Okay. To draw the speed time graph, the time you have to take along x-axis and speed along y-axis. So in the first case, the initial velocity or initial speed is 52 km per hour, and in the second case the initial speed is 3 km per hour. So the following diagram shows the graphs for both cases. So here we can see that PR is the graph of first case and SQ is the speed time graph for the second case. So now we can go to the diagram. Here PR is the graph for the first case and the initial velocity is 52 km per hour and the corresponding time we can see here, that is 5 seconds. Okay, in the second case the graph represents SQ. So here the initial speed is 3 km per hour and time is 10 seconds. Okay, so that if you are finding the areas of triangle OPR and triangle OSQ, we can calculate the distance traveled by both the cars. Okay. We can calculate the distance traveled by first car before coming to rest by finding the area of triangle OPR. So that means the area will be half BH. So we can substitute half into OR into OP. That OR is the time and OP is speed. So that we can substitute here, that is half into 5 seconds into 52 km per hour. Now this kilometer per hour we have to convert into meter per second. So that will be half into 5 into 52 into kilometer is 1000 by hour is 60 minutes into 60 seconds. So that will be 3600. And then if we calculate the value, we will get it as 325 divided by 9 meters. So that will be 36.11 meters. Also we can calculate the distance traveled by second car before coming to rest by finding the area of triangle OSQ. So that will be half BH, that is half into OQ into OS. Here OQ is the time and OS is the speed, initial speed. Then we can write it as half into 10 seconds into 3 km per hour. In a similar way, we have to convert this 3 km per hour into meter per second. So that we will get it as half into 10 into 3 into 1000 divided by 3600. When we calculate it, we will get the value as 5 into 5 by 6 meter, that will be equal to 25 by 6 meter. The answer is 4.16 meter. Now we can wind up our video here. So the rest of the questions will be discussed in our next part, And if you like my video, please like, share and subscribe. Thanks for watching.